Okay, so for the break, we started into big example tonight, the stuff from the other day, but in one specific example to hopefully make sense to everybody, help visualize what's going on with this. And before the break, we saw all our construction and interface stuff. The reasons we would need them, like we might not know the details, it's usually what it is, or just set up departments so that we know our code is going to work together. We know our different pieces of code will work together like they're supposed to, and several different reasons why we might want abstraction. We also used enums, which is just a short list. Pizza ordering, so when Zoom buttons get out of the way, yeah. It's a short list of types of crust, so that's perfect thing for an enum. We have an interface where we know our code's going to work together because everything's going to have this calculate cost method. And then in the pizza pie, we actually have the cost that we want to calculate as we add things to a list of toppings. But at this point, we don't have the details to add all the toppings, and that's where the different situations where we would want to use abstraction in our code. We have all of this. We don't need to type it every single time. This is going to be the parent of all the classes. All the specific types of pizzas we're going to make will be something that inherits all of this stuff. So we don't need to type it everywhere. We can type it once, and just the one we don't know the details for, we can just make this little note that we will fill in the details later. We know it's going to be there. We know we're going to add toppings to the pizza. We just don't know what those toppings are going to be or how we're going to add them to the pizza until we get to later details. So all of our abstraction and topping is also abstract because when we make this list, we have to be strictly typed. We could use object, that parent one that is everything inherits from implicitly, but that's really bad form because then we have a list of objects, so we can't call methods from them. We have to do casting and we have to do fancier things to, we can't rely on what type of data is there. That's our other reason for using abstraction. This class does not do anything. It's just a name, but it's abstract, and we can inherit nothing. The child classes aren't going to inherit anything, but if we do make them a child of this, it will, polymorphism will apply, and any child of this class can be used as a topping, whether it's where the details in, whether it's pepperoni or green pepper or onions or whatever else we might want to put on our pizza. It will be a child of that, so it will fit right in this list. There's all our abstraction stuff, and we haven't done the main method yet. Go back to the picture, UML diagram. I took just down below the picture was the main method. It didn't quite fit in the thing. So we have the interface. It looks like we need a couple classes, subclasses of pie. The types of pizza we're going to have, our specialty pizzas, our pre-built ones, right? The double pepperoni or the supreme or Hawaiian meaty pizzas. Yeah, all of those specialty ones that we know are going to be there. We want to make those, or a custom one, just a blank slate that we can add toppings to, depending on what the user wants. So let's make a couple of those. And along the way, we'll start filling out our toppings because we have a lot of toppings. We're probably not going to get every possible pizza topping, so we'll just make the ones we need as we put them together. So Larissa said Hawaiian pizza. That sounds like a good place to start. So I want it to be in the pizza.py package. So I'll select that and either right click here and new Java class, or there's new buttons all over the place. You just want to be careful with the new button that it does end up in the right folder. If you put it in the wrong folder, you can drag and drop here. Just like your File Explorer, regular File Explorer, you can drag and drop here, but it's probably better to just get some be cautious about as you do things. Cautious and conscientious. Be conscientious about how you do things. Just make sure they end up in the right folder. Especially starting out, because you don't want to develop bad habits that are going to have to be changed later, especially if they're things that can be predicted. So what do we have? A new pizza called Hawaiian. I'm not sure. I think one of those eyes is supposed to disappear, but I'm going to go with it. However we spell Hawaiian. We can use the little GUI here because we know it's going to inherit from pi. So we can also just browse and start searching for pi. And that's in the same package, so it should show up right near the top. Inherit from pi. Interfaces are the interface we have is on our topping, so we don't need that here yet. Public class Hawaiian extends pi. It says, let's see in the message there, Hawaiian, it's a child of pi, so it inherits everything it needs to be a pizza pie, which includes abstraction. The error or underlying there is because, well, Hawaiian is not abstract and does not override the methods, so we need to override that method. So I'm going to come in here and hit Alt Insert. Code generation is going to be a different place in every IDE, but there will be code generation for Java. We need to implement the methods. And there's only one that we're required to implement here, so let's go ahead and create that. Throw new unreported exception is what we're going to talk about on Thursday, so obviously get rid of that code that's there by default. That's going to show up in Thursday's lectures. And what do we need to do? I guess we should probably do a constructor. I'm going to add a constructor, and in that default constructor, I want to call this method. I forget something. Yeah, something looks strange here. Add topping should probably have a topping that gets passed in, right? So we can call it over and over and over again. That should have been in the abstraction. Sorry. So abstract method add topping, just like that's kind of like a setter, right? Obviously, if we're going to add a topping, we need to pass in a topping to add to our pizza. Sorry about that. A little oversight, but hopefully it makes perfect sense why that should be there, right? It's kind of hard to add something if we don't have anything to add. So then over here, when we override it, let me delete that. Delete that and hit Alt Insert and implement methods and just generate that, and then it fills all that in, and here it is. So in our constructor, when we say we have a new Hawaiian pizza, well, we need to call that add topping method. But in this case, I'm just going to pass in null. There's a couple of different ways we could do it. We could pass in things one at a time, and each one just adds to the list. That's what we'll do for our custom pizza, right? If we don't know what it is, we'll pass things in one at a time and then do that. We need to add it to the list. So since a Hawaiian pizza is something very definitive, right? We know what goes on a Hawaiian pizza. We can go ahead and just add it that way. So remember how we have toppings. our list toppings is protected, which means the child class does have direct access to it. So toppings dot add, and we can just put a new topping here, like say, is it pepperoni, ham, and pineapple? Or sausage, ham, and pineapple?
Ham, it's just ham and pineapple.
Ham and pineapple. So we need a new topping. But we want in particular ham topping, which we haven't created yet. But the little light bulb that we keep clicking on gives suggestions over there on the line number. If we right click on it, it doesn't know what ham is, so it wants to try to create a new one. Create class ham and pizza.pie. So when a lot of situations we can add this, but it's not recognizing the right thing because we need it to go over in the toppings folder, right? So we'll have to manually go create that. So I'm gonna come over to toppings. What's the keyboard shortcut? Control N or come up here and hit a new Java class. Call it ham. And ham is a topping, so we need to extend topping. And we are in the same folders. We don't necessarily have to do anything. Oh, the ham is abstract, and we haven't talked anything about the cost yet. That's where our interface, right? This is our requirements to be part of our software. This is what's going to tie everything together. And really, that's the only thing that's going to be in these classes. They inherit nothing, and then they're required to have a cost method. So we hit Alt Insert, we can implement methods, and it'll be the one right on there. Or if you want to, you can type it all. But as you can see, there's quite a bit to type. So computers are better at typing than humans. I think y'all have heard me say that before, right? Making typos is a human trait. The machine will never do that after it's debugged. And actually, when the machine makes a typo in the debugging process, that's actually the human typo, not the machine typo. The machine did exactly what it was supposed to. And all we need to do is return a double for whatever adding ham to the pizza is going to cost. It's one of the more expensive meats, right? How much should we add for it? $2.25. I'm good to everybody. So ham costs $2.25. Veggies will be cheaper or seasonal things. Maybe it's like coming on Easter, so the ham supplier decided that they could get a lot more money off ham at the grocery store than selling it at the pizza place. So our cost went up or something. Which I guess would generally be average, but does that make sense so far? See, now we have that connection part. So whenever we add ham to a thing, we get back, we can calculate the cost. And then that is the missing piece from our actual pot, the thing that's still abstract. So we'll do that for all our toppings. They'll all look almost exactly like that. They just return a different number because we don't know what the number is until we get to that topic. But we're in a different folder here, so we need to insert that. So Control-Shift-I, and from pizza.toppings.ham. The pizza object, which is a folder, and then the toppings object, which is also a folder, and that has a ham object in it. Since we are in a programming class, we should talk about those things like they are instead of the non-software development professional terminology. They're objects. Just ham and pineapple. I'm remembering like at Domino's. When I worked at Domino's, we had a third one on there. Pineapple. No, it's still not wanting to create in the right spot. It's nice when that button works because it will do the import line and everything for you. We can just go over here and create it. So we select that folder and hit Control N, a new Java class. We've seen it a couple times, so we can go faster now, right? Pineapple. Get rid of all the clutter from here. We don't need code that doesn't do anything. Then Alt Insert. Oh, whoops. Pineapple extends topping. And now I'll insert and implement that method. So notice that those lists do change. That menu is not fixed, it changes depending on what's going on. If we've already set all our getters and setter, notice there's no getter or setter button to generate. Because we don't have any data fields. So those lists are dynamic. Pineapple's gonna be much cheaper than ham, right? $1.10. I would never buy that. I bought pineapple, it's already sliced up inside the can of citrus fruit for one of my smoothie recipes. So it's with things that I know are more expensive. Pineapples like star fruit and passion fruit are definitely more expensive than pineapple. When they're cut up by a name brand company and put in a can, it's even more so. So I have no idea how much pineapple costs. An arbitrary number, and then once again, Control Shift I will insert the import line, or just type it yourself if you want to type it. But the IDE can type that for us. All right, there's our Hawaiian pizza, so we can make one of those now. What other specialties would we have? Supreme's the standard, right? The Supreme, that's one that often pops in my mind. So under pizza pie, right click and a new Java class. Supreme pizza. Get rid of all of this. I should probably go ahead and change the template instead of just deleting that every time. Supreme extends pie. And it's going to be just like the other one. We'll need our constructor. So public supreme. And it's not going to do anything but add that method which we haven't created yet. I'll insert, implement the required methods, and then we'll call that add topping. And we'll pass in null because we're going to add all the toppings at once, since this method seems to imply add one topping at a time, and we'll just call it lots of times. But we'll just add them all at once. So sorry, I paused for a second thinking maybe I should do it the other way and just pass all of them in here. Would it be too confusing if I did this differently than the first one, just to show options? There's always more than one way to do stuff. Okay, I see. I heard a definite no. So instead of doing this, this is what normal, this looks like what that, whoops, what that method is supposed to have, right? It takes in a topping and then it just adds that to the list. So we could also do that in our constructor. When we create a new Supreme constructor, we could do a new Supremes have pepperoni. Topping as in new sausage. Topping new green pepper. Oops, I forgot parentheses. Fix the little typos. What am I forgetting? Mushrooms. Oh, onions and mushrooms. Which instead of typing that topping every time, I should just be copying and pasting, right? Onions and mushrooms. So now we need to make all those classes. It would definitely be quickest if we could just click this button. spelled pepperoni wrong, but that's, I'll fix it first. Pepperoni, there we go. Right click this, and I'm gonna go ahead and create the class here. Create the class. And I'll do that for all of them. Notice it extends topping. Let me get this clutter out of the way. So it did all this stuff. The only problem is we're in the wrong package, but that's easily fixed as well. So this is kind of a NetBeans trick. I'm gonna go ahead and create all of those. Right click, create the sausage in this package and get the clutter out of the way. I should really just take that out anyway. Green, create the green pepper. Get this out of the way, oops. Get this out of the way. And I'm gonna close these. Hit save, close, save, close, save, because there's way too many things open here. We're done with pineapple. Save, we're done with ham. Save. Done with all that stuff. We still need onion. I'll go ahead and create it. And for now, I'm gonna close it. We have to do some fixing, but notice how much of the code was already typed for us. The new button would have done a lot of that stuff, but this will work as well. Save that, and then create the new mushroom class. Close that, yes, save it. And that worked, but they're all in the wrong folder. So I'm gonna select all of them. It's a file explorer, we can just select those. Holding down Control to do the multiple selection. Or if you're on a Mac, hold down Shift for the multiple selection. If you're on a Windows, holding down Shift will get everything in between as well. And just drag those over to the other folder. And notice it gave us a refactor option. It's gonna have the wrong package name, so you can see what's in those boxes. You probably never, ever want to check that box to avoid the refactoring. That checkbox should not be there. You should never avoid refactoring if it's a possibility. So with that box, the avoid box unchecked, just hit refactor. And now that brought all those in and put them in the right package name. So we can open them up and, oops. Where it did pineapple. And one other thing, notice that refactoring even got those imports. So doing it that way, go ahead and generating the code and wherever it will generate it, and then move it and refactor it, handles a whole lot of that stuff for us. It doesn't require thought. The computer can type that all day long if it doesn't require thought. We just need a few of the starting points to point that direction. Which actually means Supreme's done, so all we have to do is set up our override. So I'll insert, implement the method, which we're going to implement, which means to override that. Implement is a special kind of override. Implement is for abstract methods. So whenever it's required, it's a required override. Sausage is kind of expensive, right?
Yeah.
Let's make that more than ham. So like $3 for sausage. Save that. What's next? Pepperoni. Return to 50. It's one of the more expensive meats, but oops, that's not where it goes. I'll insert and implement the method, and here return 250. And get rid of all this stuff and return 250. Pepperoni is also one of the more expensive meats, but if we're in a pizza place, we're definitely getting the bulk discount on pepperoni. Insert. See how quickly it goes together? So that is one big change in this class from the ones you may have seen previously, is we do need to put some forethought into it in order to use all those code generators and things. What is this? Onions are cheap. Right? Onions grow anywhere in the world. Any place that supports human life is within a few hundred meters of a place that onions can grow. So those are going to be cheap. They can be grown locally, right? That's something that would be good promotional for your thing, right? Grow onions there in the windowsill, right in the restaurant. Return 0.50 cents. Something cheap. I am just making up these prices. None of these things are on my regular routine. I buy the same food at the grocery store every week. So if it was broccoli and tomatoes and celery and carrots, I would know what it costs. I would know what those veggies cost. But it's been a long time since I bought green peppers. So I have no idea. The green peppers are pretty cheap. Return 180. Just making up the number. Oh wait, that's mushrooms. The mushrooms grow anywhere too. That's like the onions. We can grow those right in the store. And I'll insert. Here's green peppers, which are cheap. So what I'm doing to delete that line is I just put my cursor somewhere on it, anywhere in that line, and then I was hitting home, holding shift, and hitting end, and that highlights that whole line in 3 key presses. Or 4 if you count the mouse click. Which is unnecessary because I believe it's Control G. Yes. So could also do, so to do that same thing, let me undo that. Maybe my cursor is way up here. I can hit Control G, go to line 14, and now hit home, shift, end, backspace. And the mouse is never involved in the process. It's way, way quicker. It takes a while to learn all those keyboard shortcuts, but it's worth your time to practice those. Return 1.05, I guess. Just making up those numbers. That gives us a couple specialties, but we can keep adding those till we run out of time tonight and still have a regular menu. That'll be enough specialties because we still need to create the custom ones as well. Where's the picture? So we have some specialty pizzas with all of those things. And I guess there is one more thing, is those, we know what the price is going to be, right? So on those 2 pizzas, it's going to Hawaiian pizza and calculate cost. So public void, can we get cost? Yeah. I'm gonna override. Actually, I don't want to use that name. Public void total. I can't think of a good word and already used calculate cost. I couldn't think of anything. I didn't want to use calculate cost because we don't have the interface. But we have a total on it, which is where it's going to call all of our other methods, right? So that sounded loud.
Get orange to the whole granola.
I hear people laughing, so hopefully it's be okay. So I'm gonna recalculate every time. So what I'm thinking for the total is, oh, those chair broke, yeah. Looks like his came all the way off. Usually it just came part way off. So double, hemp price. Actually, we can use the price. We have price, don't we? We already have a double called price. So price is gonna be set to 0. Oh, cost, sorry. We have cost. Forgot the name, forgot to change the name for some reason. Can't remember why I changed the name, but we have that variable cost, which was protected, so everything gets its own cost. So we'll reset it for 0 and then just loop through our list. So we can say, well, we saw the regular ones, right? For int I equals 0 up to the length of the list. We also saw for each. We can also do the for each loops, which is just for, there's a bunch of toppings, topping T and toppings. We can do it that way. Or our list, our linked list have their own for each loops built in. Toppings dot for each. And we couldn't really talk about this before, because see on the predictive text there, it has a bunch of stuff that gets passed in. Gets passed in a consumer. Consumer is an interface. So we hadn't talked about interfaces, but now we have. We need to actually call that. Someone uses built-in one. Because I know for certain we saw the others. Can't remember we did this. We could do a new thing and a whole bunch of stuff there, but the best way to do it is to use a lambda. If you're not familiar with Greek alphabet, lambda looks like this, or the lowercase one is something like this. Everybody see lambdas in Python? I know y'all have all seen that class before, and you actually type out the word lambda. That's a lot for one letter, and it's a hard word to spell because it has B and D next to each other. The only time that happens in English is when we're actually typing a Greek word. So they wanted to do it a little bit different in Java, so they tried to mimic that lowercase style, and they thought that if we use what's typically called an arrow, that kind of looks like the lowercase lambda. So that's how we do lambdas in Java. So we'll give it some sort of name. I'll call it T for toppings. And then some curly braces for what we're going to do for each topping. So T, then the lambda will include all of the stuff it needs to include built in the background. So that has our type data. And then we can add some spaces in those curly braces for what we're going to do. I guess in this case, we don't really need to. Usually we need to bring that down a couple lines. But in this case, all we're going to do is increment cost, right? So this dot cost increments by T dot calculate cost. There's our requirement that was necessary to tie everything together. Everybody doesn't like it. Oh, semicolon. We're inside of curly braces, so even though we're in a line, we're inside of curly braces, so we still need that. Usually it doesn't, usually we do more than one thing, right? So we split that up across multiple lines. But I thought this one would all fit on the screen. So this is probably the only time we'll see that in one. That makes sense?
Yeah.
Looks like you're-
Something I was doing my code in NetBeans for my programming assignment tonight, and it kept giving me an error, expected a semicolon, and I didn't understand where it would need the semicolon but I had,
But we have we have a large
Yeah.
block inside of a single line. So the terminology, yeah, that's a great example of looking, the text file is not what runs in the computer. So somehow the way it looks in the text file is completely wrong with what goes to the CPU in this case. Well, that was useful then. I almost did it the other way, but glad that went with that. So that's what we're gonna do for our total. That's what we're always going to do for our total. Right? Which makes it kind of silly to copy and paste this or retype it in every single one. So I'm gonna do is hit Control Cut. Because if we go back and put it in Pi, it will automatically be in all of them. So that's something we can put up here in Pi because we know exactly what's gonna happen. And all we need is the toppings list, which we already have at this point. We have our list, and any topping has to implement that interface, so we're guaranteed that that method is gonna be there. We couldn't count on that working in Python. So everybody's seen Python before. You understand why that would be a very bad thing in Python, right? We can't rely on some arbitrary variable having a custom method in it. But we can here, because we know we put restrictions, we put rules. A few more things to cover, but that's basically all the main points I wanted to make. Does that example see, you see how it fits together? We still need our custom pies, like the just custom toppings, whatever they might want. Oh, got something. We need the base cost, don't we? So, let's set up a base cost based off our crust. That's a good way to choose that. So I'm gonna add that here. Sorry, there was one more thing. We added that enum, but we haven't used it yet. So let's check and see what type of crust this pizza has. Because pizza has to have a crust. So, it's a short list, so we can just select on this dot crust. If we do a switch statement and an if else, it's different. If we do a switch, we can, it's automatic that we're using the interface. And an if else, we have to do the names. Is that confusing? You want me to type? I'll type both of them.
No, I grasp it.
Just want to make sure everybody knows. So like case, crust has that short list of these things. This is how I normally do it. I do a switch case, so I'll just, instead of typing them all like we did the other day, let me show you what I normally do. Our short list is one line. So I can hit copy, come back over here, I'll paste that in the first one. And then here, after thin, I'm gonna hit colon, hit enter, case, the deep dish, colon, enter, case for the hand tossed, colon, enter, case for the gluten-free, colon, I guess we don't really need the default, do we? And then just indent those till they line up. Doesn't look like that. Oh. Put the colon in the wrong place. But see how that copy and paste made that a lot easier? And now we can come back and add in all the breaks. So if we have a thin crust, then this dot cost increments by 12. A deep dish, I'm just making up the number of this dot cost. There's more dough, so maybe that's like 15. That sounds like a good number. Hand toss, there's more work involved, but less dough, so somewhere in the middle. 13.50. And gluten-free is always way more expensive. Yeah, at least.
Yeah, at least.
Yeah, I have to eat gluten-free. Gluten is the glue. Right? You don't know how you can make flour out of that.
Yeah.
That's the problem with gluten-free stuff is the texture's wrong. There's some really, really good tasting ones, but it's like pizza crust, just it falls apart without chewing it, and that's wrong. I used to have a great recipe for pizza. I spent years working on my pizza crust recipe. I used honey instead of sugar to make it
Steak.
extra chewy. So the fact that I can't do chewing in pizza crust anymore is just depressing. But makes sense. And if we did an if else, I'll mark it off. If we do an if else, so if this dot crust is equal to, here we have to have the enum name. We say crust dot thin. If I can spell it correctly. That's what I was trying to say earlier. It didn't seem like the sentence came out correctly. In the if else, and most places we do have to have crust dot the option, which you all have probably seen by now, right? If not, you will before long. Like colors, color dot red, and in different places. If we use this, so you can kind of see that the enumeration, enumeration is kind of intended to go with switch cases. It goes way better. Oh, I forgot something important. Nobody called me out on it. What'd I forget? Anybody? So, word switch is how I always remember this. This room here, the classroom I'm in, there's 2 light switches. If I turn either of those light switches on, I can see everything in the room, right? So once thin is on, it's going to run this code, and then it's going to run this code. And once the switch is on, we can see it all.
Do you have to turn it off?
Oh, break. We just jump ahead. We jump out of it. So we're done. We don't need to check another switch. So remember your break, because otherwise, once it hits a true statement, every statement afterwards is also true. We don't, or think of it this way: there's only one switch, so once we turn it on, it's on. That helps. Let's see, error messages. Wrote a lot of code without any test, right? Let's go ahead and finish it. I'm sure there's a bug here somewhere, but does what I'm talking about make sense?
Yes.
So I knew it was going to be at least this long, which is about 5 minutes from the time I was planning, 5 or 10 minutes from the time I was planning wrapping up. So if there's any bugs, there'll be some, hopefully you all will be able to fix them.
This is super helpful for what my project proposal is though, so.
Okay, yours is gonna be exactly like this.
Yeah.
Yours isn't a pizza place though, right?
No, it's gonna be, but it's
Similar.
a matter of. Yeah, helpful in general.
Hopefully this is very similar to everybody's project,
Yeah.
because abstract classes and interfaces are required in your project. So this is required. Let's make at least one special custom pizza. What I have in my example from last fall, what did I do fancy? So there's something called custom that is. Okay, yeah. Custom is a little bit more straightforward. I'll close these ones that are finished. We have, oh, yes, save that. I think I didn't, yeah. What's that? So we need one more pie. Okay, that. I also like to do the right click method because y'all can see very clearly what I'm doing, as opposed to hitting like Control N. That doesn't show up in the example quite as clearly. We need a custom pizza. It's gonna inherit from pi, which it's not letting me type there. So we do have to use the browse button. And when we search for pi, start searching for it, notice it brings up everything, like everything in Java. Everything that it possibly knows about that could start with PI, it starts looking there. With that first one, finish this. Got a couple requirements we got to put together. Custom extends pi, which means we need our toppings. I'll insert, implement the method, add topping. I'll do it the same way again. If I hit Control G for the go to, looks like this time it's on line 11. I'll push home. Hitting home repeatedly toggles between the indent. So hit home to go to the beginning, then hold shift and end. Can get rid of that line in just a couple key presses. Excuse me. Y'all are gonna want to learn some shortcuts like that. And we're just gonna add it to the list. Whoops. Before the semicolon, not after. Toppings.add. Whatever topping we've added. Actually. The toppings.adds at the top of the list. So if I hit tab, it's got tab. It already predicted at the right parameter, so all I really have to type is a semicolon at the end. Okay. To.add came from the predictive list, and then it predicted that I wanted that toppings parameter passed in. It wasn't much typing to get that done. So we've typed a lot of code, but this is another good example. We haven't really done much in any particular class. There's one big one. There's one thing left we haven't done yet. So we got our interface and our enum, built our pies, put all those up together. So we need a way to place the order. The ones you've seen in the textbook so far, examples in your textbook, and probably a lot of examples on YouTube and stuff, we put that right in the main method. Which should be fine for our example tonight. But what if we decide that this is working nice? We want to put this on an interface. We want to move this to someplace else, like an move this to one of our JSP pages where we can put an HTML interface together. Or if you like movie packages, like the online class is still using JavaFX, even though it was removed from the language 5 years ago. But when they were putting it together, they did a whole bunch of things. They kind of stopped pressing issues after a point. Like, okay, yeah, that's some of the more important ones went through. It's the code still exists on the internet. It's just not part of the language anymore. They just have to download it and a whole bunch of stuff. Maybe you want to put it on a JavaFX thing. Or maybe you want to make it a mobile app. Those would not require the main method. So we want to actually run this code from our own class. That way we can just, we don't have to, we have the thing that runs it and everything. So let's make an order class, which, where did I put that in the structure here? I think it's at the top level. Yeah. Here I just called it order. But now as I think about that, that might not be the best name. Order is not clear. So maybe place order would be a better name, right? And we can see in the picture, we need a list of the pies. How many pizzas are they ordering? And then we need a method to add pies to that list. And find our total, which should be fairly quick. So I'm gonna come up to the top level of the project and add the new Java class here. I'm gonna call it place order. And this is our logical class to tie everything together. And we basically want everything to happen once we do this. So what do we need? We need a private, I'll use linked list again just for consistency. A linked list of pies. So what all pizzas are we gonna put in there? Applies is a new linked list. And it's fairly common to go ahead and instantiate that. I said that earlier, Control-Shift-I to insert that. But we won't be changing our list. We're just gonna change the elements in the list. So it's not going to be a different list later. I'm move on to constructing. I'll insert. Let's make a new default constructor and let's just do everything here. Whoops. That's not a shortcut. S out and then hitting the tab is the shortcut for the system.out.println here. We'll print out to the console. Which one? Everybody's probably called a pizza place and like late on Friday night when they're all exhausted and aggravated. They just answer the phone and like, what do you want? I know you want pizza. Oh, then we better get that from probably scanner. We haven't done our in and out, so all we've seen so far is a scanner, so let's make a new scanner. I always like to do the scanners right at the top. Again, your textbook and tutorials and stuff probably say input for the scanner. That's a terrible name for it because scanners only do input. I like to be specific, so this is going to the console, which means our scanner is going to be grabbing keyboard input as a new scanner on system.in. That's just a personal thing. I just like to specify what the scanner is coming from. Because on Thursday, when we get to reading files, there's a number of ways we can do it. We'll look at fancy ways, but scanner is the easy way to read a file. So for class, other than when we look at some alternatives on Thursday, we'll pretty much be using scanners to write files. We'll just stick with the easy one and just maybe glance at a couple of the better options. And then we can grab this. So a string, probably type is the keyboard dot next. What do you want? Specialty or custom? That way we know which one we're in, because now we can do a selection structure, right? If they want specialty, the options are either Hawaiian or Supreme. Yeah, so if type dot equals specialty, probably could use some handling there. I'm just gonna make sure everything's typed in lowercase. But that's that part's not too difficult. Now just make sure everything's typed in lowercase. If they want specialty, then we say all we got left is Hawaiian or Supreme. And then actually we can keep using that type. I'm gonna change that to user input. User input, because the user only we're not going to keep what the user says, so user input is keyboard.next again. I think this is setting up a trend y'all all recognize, right? If user input dot equals Hawaiian. And again, there's probably some error handling we could do in here. I'm just gonna make sure everything's typed in lowercase. If they don't say Hawaiian in lowercase, they get a supreme. That sounds like a good way to do it. In that case, what's a good way to do this? We need to keep track of this pie. Actually, it's specialty one though. They get a Hawaiian pizza. There's no customizing it. Not at our restaurant. They get what we send them, right? Yeah. So a Hawaiian pizza will just say the list of pies. Pies dot add new Hawaiian. And we need to import it. Control Shift I. And it looks like it imported the correct thing, just Control Shift I. Otherwise, if they didn't say Hawaiian, then they're getting the Supreme. And hopefully by this point, y'all can, whoops, that's not what they're getting. They're not getting the word Supreme, they're getting a new Supreme pizza. Control Shift I. Did the import, maybe glance to make sure it imported the right thing. Always a good idea to confirm that instead of just trusting it. If they didn't say specialty, then they want custom. So for that, I'm gonna set up a pie. Call it next pie equals new custom. Import that. And notice the abstraction again. The type is the parent, but what we actually put there is the concrete version. So the type on the left is abstract, type on the right has to be concrete. Or polymorphism. Custom pizzas are polymorphic to pie in our case. As how what toppings do you want? We're running out of time. So whatever they say, I'm going to say, oh, you can have green peppers. Y'all can change. I have faith y'all can do something more interesting with that, right? We're quickly running out of time, so I'm just going to say they can have green peppers on the back. So in that case, we'll say next pie, add topping, and we want to add a new green pepper to it. Which I think needs imported. Yep. We probably want to put all of this in a loop so we can keep asking, right? You want another one. After we do all that, get a pie, system out. Want anything else? A new while loop will work good for you. So then I'm going to come all the way back up to here. And I'm going to indent that one level to keep track of it. And up here say do in a curly brace. And then down here, while user input does not equal no. user input dot equals or no, and then put the not symbol in front of it. So while not user input dot equals no, we'll keep going. So I guess we need to see what they said here. So user input is assigned keyboard dot next. Anything else? It's a yes or no question. Oh, I think I need a curly brace here. Yep. And I need user input to exist outside of that. Is a new string. So then here we just keep using that same string over and over and over again. We only have one thing there at a time. Hopefully all that makes sense. It looks like it's not going to quite fit on there. So, well, it's do while, so it's guaranteed to happen once, right? So we answer the phone and then at least once the order gets placed. We get to the end, want anything else? Yes, and if so, then we go back up here to what do you want? All that hopefully makes sense, right? All of it's in one nice consolidated place, and it's not our main method. It's actually in the default constructor. So now to run all this, there was a little red X there because the compiler is what checks all of that stuff. And I'd made some edits since the compiler last checked. So a way to accelerate that is if you go ahead and hit save, Control S, I just did it out of habit. Go ahead and hit Control S, that forces the compiler to run. So then it will go ahead and check everything. In your IDEs, that forces it. So now to do this, our main method just needs some place order type of data. I'll call it PO as a new place order. And then our default constructor should catch the lines. This is much more common for what a main method would look like. It has one line that all that one line does is start your code, which is somewhere else. Everything in a textbook, and that's standard for all textbooks, not just our author, and tutorials on YouTube, they try to go ahead and shove the whole example into the main method, which is very unusual. It also prevents us from hitting that static, non-static error. Remember, we saw how to fix that. We just instantiate it. But usually that never happens because all we do is all of our logic is in a different class somewhere. So the main method is only one line to instantiate that class to start. The Java virtual machine starts here, then our program, then the one line to start our program on the Java virtual machine. A much more common thing. Probably full of bugs, right? We just did the entire project without debugging, without a single test run. So let's see what happens. Probably nothing good. So haven't set our main class, so it's predicting the right one. If you put main classes and other things for test cases along the way, like anything that's not abstract, we could have included a main class and put it there, but it is good form to separate them. Have your main class separate. But if there's more than one thing, you'd see them all here. Yeah, that's the only one we have is what we've got. We want specialty or custom. I'll try specialty. All we got left is Hawaiian or Supreme. Hawaiian. Oh, I guess we probably could have printed out the price somewhere, couldn't we? We have a method that calculates the price. Where was our method that calculates price? It's over here, right? What we call total on each of those. So in place order, let's make a new double. Price, and we probably want the decimal format as well. SDEV is a new decimal format. Things we've seen before, and it's money, so 0.00. Definitely include all of those places. Control-Shift-I to import that. And then afterwards, after we do all this, then we want to run that method. So our list, where's our list? Oh, actually, we didn't need this, did we? Oh yeah, I remember what I was doing. Then we need to add this to the list. Pies dot add next pie. Sorry, that line was left off. That would have been a bug we couldn't tell was there. We'll add that to the list, and then down here we can just do pies dot for each. And our consumable will make that a thing. So P, lambda, some curly braces. And this time I will go ahead and spread those out. For each pie, we want our price to increment. So price, we should probably start at something. Price equals 0.0. We'll start it at 0. And for each one of our pies, we'll increment by the price here. Do we call the price? We call the total here. Plus equals P dot total. Oh, this should probably be returning a number, right? Double, and then after we do all this, then we return this dot price. So I'm jumping to arbitrary places. Does everybody see where I went and did that?
Mhm.
So where we did the total is dot cost. Change that word earlier. Same thing that's written right above it. We would need to return that. So then when we're placing the order, we can add it to our price and keep incrementing. And then we say, that's gonna be, next line we'll say, I'll do it here, pies dot for each. Remember what happens when we just hit print pie? We get crust, cheese, sauce, toppings, and price on that particular pie. So for each, then another lambda P, lambdas into, whoops, I did not like that at all. Let me try that again. System.out.println P. We'll just print each one out on a separate line. Then for a total of plus this dot price. But we probably want to use the format. df.format this dot price. So getting a little bit fast there at the end, but did everybody follow along? Make sense of what's going on there? I see heads nods here. Save that. It's not showing any syntax errors, so we come over here and run it. Let's see if we can actually get an order. Specialty. I want a Hawaiian. Anything else? Nope. Oh. Oh, so here's the error message we had the other day. This dot crust is null. Oh, we never set the crust, did we? That's the, where's our crust? So when we check the crust, switch cases cannot handle null. There has to be something there. So I guess we better ask people what type of crust they want, right? We get this. So what crust did you want on that? So maybe out of order, but then we can do next pi dot set crust to scanner. Oh, whoops, not scanner. Keyboard dot next. I changed up what I was doing a little bit there. There's no need to store that string, right? All we would do is store that string and then use it on the very next line. So we could just put that, we could just go ahead and pass that right in there. The computer will keep track of it. I haven't really seen that. I guess we're gonna do that up here. We better do that before. I'm gonna copy these. New line. And then press. Oh. We need a selection structure. I'm gonna abbreviate it. All we got left is deep dish. So we're gonna act like we're sold out of things. So then we can just do crust dot deep dish. And import it. So I'll copy that, paste that here. That, paste that here, and this one's gonna be supreme. And then here, we just need to pass in next pi instead of doing it explicitly up there. So there was nothing new in the end there, but I made a lot of changes. Does that make sense? It should be an easy extension to add that to the scanner, right? You'll just need to probably put a better prompt than I did there and ask that. So for fixing those prompts and things and finding debugs, I will put some extra credit on there. Normal ones are what, 35 points? So let's do a third of that. So 12 points if you, at the very least, you can fix those prompts. It might not crash right now. Specialty, we want a specialty. Hawaiian pizza. Nope, that's all. And it didn't crash. But it is certainly not finished. So fix those prompts. It should be easy, right? Ask the question, run through a selection structure to see which type of crust it is. And while you're doing that, I'm sure there are bugs in there somewhere. We just typed code for 2 hours and 40 minutes minus a 10-minute break. And without doing any test runs. We should never ever do that. But we just did that. So I can pretty much guarantee there's bugs in there somewhere. So if you improve those outputs, prompts, fix that little running thing, make some improvements on it, find bugs, fix them, that'll be worth 12 points of extra credit. And I will set up an assignment to turn that in. Are there any questions on that? Do you all kind of see, does that make more sense than just the way the textbook writes it and pure theory or the little pieces we saw the other day. You see how useful that stuff is. I know I heard a couple comments this evening about, at least from those in the classroom, about how it's going to apply to your projects. Which is very, very good, because those are the main requirements of the project. The other stuff is supplemental. That is the core Java programming. Please get that on the project. If you can't get the interface right and fall back, if you're having trouble with Spring Boot and need to fall back, drop all that other stuff, but please get this part right on your project. The abstract class, the abstraction, and the interfaces, please get that right on the project. That is by far the most important thing. The other stuff is because that's what you want to put on your resume. After this class, you want to put Spring Boot on your resume because that's what employers are be looking for. That's what the other part. The other part is just so that you can honestly put it on your resume and point to something on GitHub that you've done with it. This is the part that really matters as far as Java programming. So if you have any questions about that, let me know. Hopefully that made sense. This will be put on GitHub here before long, and an assignment will be added to Ivy Learn so that you can get 12 points extra credit for fixing up those prompts and seeing if there's any bugs, because we test code for 2.5 hours without a test run. So I am quite certain that there's a bug in there somewhere that needs found and fixed. Otherwise, everybody okay on the midterm exam? It's the debugging assignment. So I guess that kind of takes off from the debugging assignments. Remember that exams are not on the same schedule as homework. Please get those to me by Saturday at 11:59 p.m., the end of the calendar week. No late submissions on exams. Otherwise, I will see you on Thursday. Everybody have a great night.
You too.